Students, the next we are going to learn about the structural isomerism. So what is the structural isomerism? Your nose. Same molecular formula, different structures of the coordination compound. That is called the structural isomerism. So the first thing is the linkage isomerism. So in this linkage isomerism, it is dependent on the ambidendate ligands. So what is the ambidendate ligands? Two different donor atom is there. So this is the example of the ambidendate ligands. NCS, NO2 minus and Cn minus. Here the nitrogen and the sulfur is the donor atoms. So here the two different types of the donor atom is there. Here NO2. So sometimes the nitrogen is a donor atom and sometimes the oxygen is a donor atom. Here the cyanide, carbon is a donor atom as well as the nitrogen is the donor atom. Okay. So there are two different donor atoms in this ambidendate ligand. So it is called ambidendate ligands. Okay. So it is only differ the linkage of the donor atoms. So what is that linkage of donor atom? I will explain the two examples. Okay. I take this complex. Here the nitrogen is a donor atom because the nitrogen is attached to the connected or coordinated to the cobalt atom. So here the nitrogen is the donor atom. So the nitrogen is donate the electron to the central metal atom. But in this complex, here the oxygen is coordinated to the or connected to the cobalt. That means that oxygen donate the electron to the central metal atom. Here the oxygen is act as a donor atom, but here the nitrogen is act as a donor atom. So which is connected to the central metal atom means, okay, that ligand is act as a donor atom. Okay, so in this depend on the donor atom, they can linkages are different. So the linkaging of the donor atom is present in here means that is called the linkage isomerism. So here it is this complex is a red in color and this complex is the yellow in color. Okay, so only one cobalt here and there, and also 5 ammonia here and there, and 5 ammonia is there. Also NO2, same molecular formula, NO2. Here is NO2 and there is also NO2, but it is a connection of the ligand to the central metal atom is nitrogen here and here is oxygen. That is a different. So that is called the linkage isomerism. So what is the next topic is the coordination ligands. What's a coordination isomerism? What is a coordination isomerism means? They are only the distributions of the ligands is there. So what are that? Here two type of the metal is there. So it is a bimetallic compound in this coordination complex. Bimetallic compounds. Here cobalt and chromium is there. Okay. The first complex, cobalt is connected with 6 ammonia and chromium is connected with 6 cyanide. So what is the isomerism of this complex? This is the isomerism of this complex. What is the isomerism? There is a second thing. It's isomerism of this complex. What is the isomerism? Change of the metal atom, central metal atom. So this chromium is attached to this ammonia and this cobalt is connected to this cyanide. So reverse of this complex, it is a isomerism of this complex. That is a coordination of a complex. So that is also, it is a same type of the ligand. It is a homolytic ligands. It is a heterolytic ligand. So different type of the ligands is there. The example of the heterolytic ligand is there. So it is a coordination complex. What is a coordination? They are the distributions of the ligands. Only the distributions of the ligands are varied. Okay, so this is the isomer of this complex and this is the isomers of this complex. Here that tetrahedral complex, the platinum is connected to the or coordinated to the 4 ammonia, and here the palladium is connected to the chlorine atom. So this palladium is going to connect it to the ammonia, you get it, and this platinum is connected to the chloride atom, so you get it this. Okay, and what is that? Next topic is a ionization isomerism. Next point, next heading is the ionization isomerism. So what is the ionization isomerism? So this type of isomerism arises when an ionizable counter ion itself can act as a ligand. So here the isomers gives a different ions in a solutions. The isomers gives a different ions in a solution. Where you use the solutions in that complex, that the isomers gives the different ions in the solutions. Look at this. Second thing, this is the counter ion. You know, everybody knows this is the counter ion. So this counter ion present in a solution means, this complex present in a solution means this counter ion is act as a ligand, and one type of this ligand is act as a counter ion. The exchange of the counter ions are going to change as a ligands or a counter ions. Okay, that is it. So what is the example of there? This is the dissociations of the ions. Ions are, I write it here. This is for your understanding. So not write this blue color. So only you write that this only. This is the complex and this is the isomers of this complex. This is the complex. This is the isomers of the complex. This is for your identifications only. Your understanding only. I can write this. Okay. What is this? Here 5 ammonia and SO4. Br is there, you know. Now what do you get? That isomerism of this counter ion is going to change in the ligand, is act as this bromine is a counter ion. So if the bromine is act as here the isomerism of this complex, the bromine is act as a ligand, and this SO4 ligand is act as a counter ion. So exchange of the counter ion and the ligands here. Okay, and same thing, and the next thing, it is a ethylene diamine. It's a ethylene diamine. So there is a bidentate ligands. Okay, bidentate ligand. So exchange of the bromine in the complex, the counter ion of the bromine and going to here, and the ligand of the chlorine is going to there. So okay, so that is ionization isomerism. So example of the ionization isomerism is here. And what is that fourth one? Solvate isomerism. So solvate means you have to use the solvent here. So what is the solvent? Water, ammonia and alcohols. You have to use the solvent. And then it is denote the crystal lattice solvent molecules. So what is the crystal lattice solvent molecules? The free solvent molecule in a crystal lattice, and otherwise the metal ligand solvent molecules in the crystal lattice. So this is the free solvent molecules, and this is the metal ligand solvent molecules of the crystal lattice. Okay, suppose you have to use the solvent as a water means that isomerism is called the hydrated isomerism. Here the solvent molecule is used, water molecule is solvent is used in this complex. So it is this complex is called this isomerism is called the hydrated isomerism because the solvent is a water. Water is used means it is called a hydrated isomerism. Molecular formula of this complex is CrCl3 and 6H2O. 3Cl and 6 water molecule is there. Okay, but how can you write in this metal ligand solvated molecules or free solvent molecules? How do you write means here 6 water molecules right here and 3Cl3 in the counter ion. So that is color is a violet color, but the next complex one of the water molecules is going to there and one of the Cl molecule is going to inner of the complex. 5 plus 1 6. So remaining is write it the counter ion. Write as a counter ion. Okay, so that this is represented as a this is give the color like a pale green. This complex, this isomerism is gave the pale green, and next Here the 4 water molecules